Well, I have disassembled my Beckman Industrial Scopemate 2 and IC and component tester, and I'm going to throw the circuit board and the knobs and probably the ZIF sockets into the ultrasonic for about 10 or 15 minutes to clean them up. Over here I replaced the main electrolytic capacitor, and then also that tantalum. Probably really wasn't needed, but no sense in messing with this thing later on down the road if one of the two causes a problem. So just get it out of the way and do it now. So the ultrasonic's up to about 44 Celsius. I have it set at 50. I've been waiting for a couple hours. Tired of waiting, so I'm going to throw it in there and start cooking it. And she's cooking. Well, that certainly is looking better. Ran it for about 15 minutes in the ultrasonic. Pulled it out, blew as much water as I possibly could out of it, and then let it sit in the hot baking sun for a couple hours, and it's probably about ready to go. Definitely a lot nicer than it was. I didn't do the little power supply section. There really wasn't any need for that. And let's see here, I did the ZIF sockets and the knobs. These, I was afraid that it was going to take the ink off, or the glue off that cover, so I didn't do those that way. What I did do is I used car wash detergent in hot water. It didn't clean up very nicely, but that's probably not going to. It looks to me like this thing was probably used in a repair shop. It's got burn marks on it, and it absolutely reeked of cigarette smoke. So it's probably had a hard life. I'm kind of curious once I start testing this thing if a bunch of these switches don't work very well. It might be noisy. And also, I didn't get any of the 20-pin ZIF sockets, but I do have some 16-pin I might try just for testing. Put them in there and just note which hole that they're in, I guess. And then also the AC adapter that I purchased from Jamico doesn't have the right end on it. I happen to have a 10-volt one that I got from All Electronics, I don't know how long ago. It does have the correct end. So I might try to disassemble that and put the cord on here, just because I'd really like to get this thing going this weekend. I don't have very rarely get any time off of work, so when I do, I like to be able to finish a project. But I'll come back whenever I make more progress. So I've got it all back together. I made a decision that I'm going to use the 10-volt wall transformer at the moment, and I have the correct receptacle on the way from All Electronics, but I want to test this thing this weekend to make sure it's functional. And I might not have 8 days off for now until who knows when, middle of August. So 10-volt transformer should work perfectly fine. You just won't have quite as much voltage at the test sockets. It definitely runs the alternating display. So I'm going to try it with the 10 volts and see if everything works. Check all these switches, see if they're noisy or even functional for that matter. I suppose I could have flipped the thing over with a multimeter and checked every one, but it'd be easier just to do it with a component in the circuit. So I'll get the Beckman 9020 oscilloscope out, have those all hooked up, and we'll test a couple components and see what happens. Well, I've got everything back together here, and it's time to do some testing. I've got it hooked up to the Beckman scope, and I had to do a little bit of goober cobbling here, unfortunately, because it would, for some reason, it would not run off 10 volts. So it doesn't matter. I have a couple jacks and a couple receptacles on the way, so I can replace what was there on both power transformers, or little whatever they could call them, wall warts. I've got a couple 2SA 950 small signal transistors in here in socket 1 and socket 2, and we'll start off some of the comparison testing with it. Turn this on, and obviously pin number 1 is going to be dead short because that's what you're referring to, and then pin number 2, and you can see it flashing back and forth between both sides. Now for some reason there seems to be a difference between each side regardless if there's a component in there or not. That's why it expands and contracts a little bit. I'll have to do a little research on why that is. Maybe the little relay in there is getting bad. And then there's pin 1 to pin 3. So you can see you can compare a transistor fairly easily that way. If I could take care of that weird expansion and contraction, you could almost maybe use it to match transistors. I'm not sure, but I've got other stuff I can do that with if I wanted to. But next up, I'm going to put a couple NE555s in there, and the two that I have are the first two I'm going to use are going to be from the same manufacturer, and then I'm going to put one in from a different manufacturer, and you're going to see that there could possibly be a different signature from different manufacturers. Okay, so I've got two NE555s, one in each socket. They're both from STI, I can't remember what the heck they are, STI Semiconductors, Micro Devices, whatever, it doesn't matter. They're both the same manufacturer, so hit pin 1, of course, that's going to be dead short because that's what you're referencing from. Pin 1 is the ground. Okay, pin 2, you can see they're about as identical as you can get. Pin 3, same thing. Pin 4, and go up here. Pin 5, pin 6, pin 7, and pin 8. Now next, I'm going to put an NE555 in the test side that was manufactured by Texas Instruments. Okay, next up we've got the NE555 from Texas Instruments. So let's go through the comparison testing with it. It is in the test side, and the reference is the STI one. Okay, pin 1, of course, dead short. 2, pretty close to the same. 3, nearly the same. 4, the same. 5, a little bit slightly different kick, but pretty close. Now 6, look at that. That's a huge difference. I know both of these are brand new and they're both good. But yeah, the Texas Instrument one is way different on the threshold as compared to the STI one. And then 7, pretty much identical. And 8, slightly different on 8. But that's a real pitfall you could get into if you're doing comparison testing back and forth. If you have different manufacturers, they're going to accomplish the same thing differently, possibly. So the signature may not be the same just because they're the exact same type number, NE555. So that's something to be aware of. I came a little bit unprepared this weekend. I was going to test, I had some bad ICs from work I was going to bring and test them with some new ones. I have the bad ones, but I don't believe I have any new ones to compare with. But I'm going to look around and see if I can't find some. And if I do, then we'll test that. If not, well, maybe we'll do it some other time. Okay, so I looked around and turns out I did have another capacitor to capacitor IC to match the one that I had brought home from work that had failed. This is a CD4066 analog switch. We had some trouble at work with a input card on a temperature monitor with these failing constantly during a powder coating process, and eventually I determined that the static electricity from the powder coating was frying these ICs, so I specified that they completely remove the thermocouples from the input of this module until the powder coating was done, then connect them. But anyways, I've got a good one here in the reference side, and the bad one is on the test side. There are different manufacturers, but it becomes very obvious that the one in the test side is definitely bad. What it does, it pretty much goes open circuit, volt to ground. If you ever tested one of those volt to ground, they have a, I assume like a protection diode across there. So when you test with your multimeter in one direction, you'll get infinite, and then when you test in the other direction using the diode function of your meter, you'll get like a diode drop, say 0.6, 0.7 volts. And that's how I pretty much determined that they were bad. Then I replace it and then it works. But this here would be a good way to also do it if you had one of the same manufacturer. But again, I know this is bad, so, and it becomes quite obvious it is bad. But anyways, we'll hit pin 1, and as you can see, the 1 is completely dead. Pin 2, same thing. Pin 3, you got something goofy going on there in the test one, but for the most part it's dead. Pin 4, now notice the consistency depending upon whether it's an input or an output on the good one. You can kind of if you'd study that signature, you would know where you're at, whether it's an input or an output. Okay, there's pin 5, pin 6, pin 7. Of course, pin 7 is the common. Let's see, I don't think there's a pin 8. But see, even on that, it shows a different. Okay, I'm not going to edit the previous section out because, hey, let's make it reality, right? Because sometimes you make mistakes. I didn't change the common jumper on the test one for this particular IC, which the common is on pin 7. I didn't realize that until I got to pin 7, and I had 2 different readings. I'm like, what the heck's going on here? But I'm not. Let's go through that test again, and like I said, I'm not going to edit out my mistake because, hey, keep it real, right? But anyways, we'll do this again. Pin 1 still shows the same, that because the IC is dead. I know that for a fact. Pin 3, pin 4, pin 5, pin 6, pin 7. See, now pin 7 is the same. That's the common, so it shouldn't have been changing. Okay, pin 8. Get the right one there. Pin 9. Pin 10. Pin 11. Pin 12. Pin 13. And pin 14. So as you can see, the IC under test is totally shot. It's no good. And this is probably one of the best ways to do that, because I did notice as I was going along there with my multimeter looking at diode drops, the inputs and outputs still look the same as what the good one does, but that IC is totally dead. And this is kind of a good method. You put that on the ground side, and everything somehow, somewhere, eventually references to ground. So if nothing does reference to ground, then that IC is no good. It's that simple. So I just thought I'd show a couple examples here, and hopefully somebody might learn a little bit about this, or maybe you'll have some extra input about it. That would be great too.